Hey guys, so today we are going to be going over LeetCode problem 804, unique Morse code words. In this problem we are given a list of words, and what we have to do is return the number of unique Morse code strings these words make. As we see with Jin and Zen, multiple different words can both be represented by the same string in Morse code. This Morse code string is made by concatenating the Morse code representation of each letter in a word. Our job is to return the number of unique Morse code words, referred to as transformations, that can be created by the words in the words array, with the caveat that the length of the words array will be at most 100, and every word will have between 1 and 12 inclusive lowercase letters. What we want to do is go through each word in the words array and construct a string containing its transformation. The way we will do that is by going through each character in the word and concatenating its Morse code value from the given table. Then we will add this string to a set. We will do this for each word in the words array. At the end, the size of the set will be how many unique transformations we have. This is a feature of the set data structure where it does not contain duplicates. Going back to our earlier example, if the transformation of Jin was already in the set and we tried to add the transformation for Zen, nothing would happen and the set would remain the same size because the two transformations are the same. To start our implementation, we will first copy over the table of values given to us in the problem statement. We will use these Morse code values later on. We will then create our set of strings that will be used to store the transformations. This will be done by creating a hash set. Then we will use a for loop to loop through each word in the words array. Then, for each word, we will need a string builder, and then we will use a for each loop to loop through each character in the word. We will grab the ASCII value of the character by casting it to an int. And then, because A in the key array corresponds to index 0, we will subtract 97 from the ASCII variable. This is because in the ASCII chart, lowercase a is 97, lowercase b is 98, etc. This is a good piece of knowledge to keep in mind while doing coding interviews. After we create the entire transformation of a word, we will add it to our set. Finally, we will return the size of the set to see how many unique transformations can be created. We go ahead and click submit, and we see that our submission was successful and was in the 100th percentile for speed. In terms of speed complexity, our algorithm is constrained by the number of words and the number of characters in each word. Our entire algorithm will be O of n times m, where n is the number of words and m is the upper bound on the number of characters in each word. Getting the size of the set is an O of n operation, so it doesn't matter. Adding an element to a set is also O of 1, and we potentially do this n times. However, this O of n operation gets absorbed into the O of n times m runtime. The space complexity would be O of n because the set we are creating could potentially have n strings in it. And that will do it for today's video, so be sure to like and subscribe and let me know if there are any problems that you guys would like to see me do.